Okay, we are going to take a quick look at homework number 2 that was due yesterday. This homework is dealing a lot with landscape is what I need. Hold on a minute. There we go. Dealing with equations, systems of equations. I'm going to start looking at number 1. The first thing is asking you what the two variables are. From this pull-down menu, hopefully you picked X and Y. They also want you to determine whether this is a solution, and basically you would have to plug in 6 for X and -1 for Y, and they would have to work and make a true statement in both of the equations right here. But then they go ahead and they ask you, well, which one of these is the solution? Select all that apply. So what I'm going to do is I'm going to throw this into Desmos, and hopefully Desmos has a very clear and concise solution to this problem. So here we are in Desmos. I'm going to go ahead. I opened up a specific kind of window, so I'm just going to make sure I don't. 3x plus 4y equals 13. And then in the second one, 2x minus y equals 5. Then I look and see that this is 3, 1. That is the solution. So I'm going to go ahead and put that in here. There we go. Okay, so, and I'm just going to go ahead and get rid of this calculator for now, and we'll keep going. Use a substitution method to find all of the solutions. They want us to use a specific method. The substitution method basically can be used if I can isolate a variable. In this case, x would be very easy to isolate if I add y to both sides. So now I have x equals y plus 1. These are essentially the same thing written 2 different ways. How this helps me is anywhere I see x here, I can replace that with y plus 1. 4 times y plus 1 plus 3y equals 18. 18, plug it into there. I'm going to distribute my 4. I have 7y equals plus 4 equals 18. Subtract 4 from both sides to get 14 and divide both sides by 7. So y is equal to 2. So I have the y. I'm going to put that here, but I need the x. So I'm just going to plug this in here to one of my original equations, and that tells me x is 3. If I want to double check this, I can do that on Desmos. They want us to do the same thing with number 3. Again, I would change this one so that it's written as y equals -2x plus 1, because I could subtract 2x from both sides and isolate y. Then I will rewrite this, but instead of y, I'm going to put -2x plus 1. Use my equation solving skills to solve for x, and then go back and find the y, because when you solve a system, you have answers that are in the form of ordered pairs. Use the elimination method. Means I want to eliminate either the y's or the x's. The thing is, these don't line up. When I say that, if I want to eliminate a -3y, I would need a positive 3y. Or if I wanted to eliminate a 8x, I need a positive 8x, like negative positive. So I can do this. I can manipulate the situation if I multiply this entire row by 2. Every piece. 8x minus 6y equals -44. My original second row is going to come here. And when I combine these by doing vertical addition, I can cancel out the x's. I have y equals 2 when I combine. So I have y. I need x. I'm just going to go back to my one of my original equations. Doesn't matter which one. Plug in 2 for y so that I can solve for x. Plus 6 plus 6, 4y equals -16, and 4 goes into -16 4 times, so y is -4, or I'm sorry, not y, x. This whole time I'm supposed to be doing x. There we go. Goodness gracious. So -4 is my x value. I like to just have a little fit of dyslexia there. Okay. Use the elimination method, same idea. I would go ahead and change both of these rows to try to eliminate y's by multiplying this whole row by 4 and this whole row by 5. 8x minus 20y equals -72. And then I have 15x plus 20y equals 95. When I combine these, those y's go away. I have 23x equals 23, and x is equal to 1. Once I have x, I can plug it in to any of my original equations to find y. And if I subtract 3 from both sides, 4y equals 16, so y must be 4. There. Okay, 2 equations and their graphs are given. Find the intersection point. I could throw this into Desmos if I don't trust my ability to identify. I think this is -3, comma, looks like -3, comma 6. But I would definitely throw that into Desmos to just double check and make sure that I'm accurate. My lines are accurate because I don't want to get it wrong over something kind of dumb. This one says, graph the linear system by hand or graphing device. Easy to do as long as I put this in slope-intercept form. So I'm going to add y to both sides and subtract 7 so that I get y equals x minus 7. Now I can go ahead and I can graph this, right? There it is right there. I'm going to do my best to, I know it's not a beautiful thing because I don't have a ruler. And again, I can subtract 2x from both sides. So I have y equals -2x plus 8. Here's 8. And here's -2. I'm just going to keep going down here. I know when they do this, it's a little bit better, but the solution for this is 5, comma, -2. One solution, 5, comma, -2. Let's go down here. What did I do? Did I make this one piece big? I think I did. I don't know how I did that. Wow, that's amazing. What's going on in the world? Let's bring this one down here. Well, that was a little crazy. I've never had that happen before. I'm going to move this over here. I don't want to have problems later. This one's graph the linear system by hand or use a graphing device. If they tell me I can use a graphing device, you better bet your butt I'm going to throw this into Desmos. The thing is, when I throw this into Desmos, it's great. Give me an answer. But I still think that they are going to grade me on whether or not that appears here. Now, I'm going to tell you right now, this is an uncomfortable situation. I can multiply both sides of this by 2. And what's going to happen is I am going to find that this is -2x. The 2's cancel, plus 5y equals 20. Okay, that's nicer. I like that. If I was doing this by hand, that would be a thing I would have to do so that I could solve for y. If I solve for y here, that is -5y equals -2x plus 20. And if I divide everything by -5, I get 2 over 5x minus 6. If I do it here, again, I would add 2x to both sides. So I'd have 5y equals positive 2x plus 20. Divide everything by 5. Y equals 2/5 x plus 4. Notice I have a matching slope, different y-intercepts. Here's a y-intercept here, rise 2, run 5, boom. Here is a y-intercept at -6, or I'm sorry, positive 4. If I rise 2, run 5, I have parallel lines. Parallel lines have no solution, and I have to type no solution into everything. No solution. If you put this right into a graphing utility, you'd have seen that right off the bat, that those lines are not, there's no solution. Taking a look at the next question, it says to graph this by hand or by using a graphing device. Of course, I'm going to use a graphing device because that's the easier way to go about it. But if I was going to do this by hand, I would put these in slope-intercept form by solving for y. So I'll tell you right now, this first one, my first step would be to add x to both sides and then to multiply every piece by 3 to get rid of this fraction. That would make this be y equals 3x minus 9. If I were to change this one to slope-intercept form, it would be first negative y equals -3x plus 9. Multiply everything by -1. I get y equals 3x minus 9. notice that this is the same line. This is the same line. So you would know this immediately if you did this on Desmos, because you would only see one line and you'd zoom out, zoom out, zoom out, and then you'd figure it out at some point. If it's the same line, then it has infinitely many solutions, and you would have to write infinitely many in here. And I can't spell it, and I don't care. Okay, number 10. Solve the solution, show that it has a solution. Again, by this time, you've got several different tools under your belt for this. I'm not going to keep doing these over and over and over again because, I mean, we've done a bunch of them. Again, solve it. You could do elimination, substitution, or graphing. Let's go to number 11. I'm just going to show you how to set this one up. This one right here, we're talking about admission fee, and we're talking about how many people. So C is going to be children, and A is going to be adults. And so there's two things I'm going to do here. I'm going to focus on the cost aspect and make an equation that says $1.50 per child plus $4 per adult is going to bring in $5,200 on this particular day. I also can say that this many children and this many adults is going to equal 2,300 people. The problem with these kinds of things is really writing out the equations. It's not as much solving the equations, but I can tell you, if we were going to solve this the whole way, I would be multiplying this entire row by either -4 or -1.5 to either cancel out the A's or the C's. Remember, you have to find the price and cost for both children and adults. 14 is the same kind of idea. We're talking about regular gas. We're talking about premium gas. I can look at the cost and I can look at gallons. If I buy R gallons of regular and P gallons of premium, 240 gallons is what that's going to total. If I pay $2.30 for every regular gallon and $2.90 for every premium gallon, I have spent $594. Again, here's the system. If you were going to start to solve this, the first thing you can do is manipulate that top row to either cancel out the R's or cancel out the P's. Fruit stand, same thing. We have standard strawberries and we have deluxe strawberries. Standard is $7 a box, so $7 for every box of standard, $11 for every box of deluxe, and they brought in $950. And if I add up how many boxes of standards and how many boxes of deluxe, I have sold 110 boxes. Here's my equation, and then I'm going to go ahead and try to figure out how many boxes of standard versus how many boxes of deluxe. Okay, we're getting to the nitty-gritty here. This man is going to fly in a small airplane from Fargo to Bismarck. Really important to know this one because this is on the exam, one very much like this. It's a distance of 180 miles, and he's flying into a headwind, and the trip takes him 2 hours. So normally we would say that he's flying in still air, and then there is a wind that is either going against him or it's helping him. So basically on the way back, that same headwind is happening, but it's helping him on the way back. We need to set up a system of equations, and we also remember that distance equals rate times time. So that's a thing that is really important to know. The thing is, if I am looking at x being still air, the speed of still air, and y is the speed of the headwind, on the way down, I can say that the rate is still air minus the headwind. And the distance is 180, and the amount of time it takes him to go down there is 2 hours. So this is rate times time equals distance. If I'm on the way back, I have that still air, but I get to add into it the speed of the headwind. On the way back, it takes 1 hour and 15 minutes, and we're still going 180 miles. 1 hour and 15 minutes, if I convert that to just hours, that is 1.25 hours. 15 minutes is a quarter of an hour. Here is my equation. I'm going to distribute my 2 and distribute 1.25 and then solve this system to find the distance or the rate of the still air, the speed of the still air and the speed of the headwind. 1.25, the airplane speed is what I'm really trying to say. Okay, so this is what you would do right here. If you were going to go ahead and try to cancel out something, I guess I would want to cancel this out. So I'm just going to multiply this entire row by 2 and this entire row by 1.25. And what that will give me for my new rows is, I'm going to have to kind of go above here with this because I'm running out of room, and I'll use a different color. So taking this up here, I have 2.5x minus 2.5y equals 180 times 1.25, which I didn't do yet. 180 times 1.25, 225. And then I have 2.5x plus 2.5y equals, oops, hold on a second. Yep, equals 2 times 180, which is 360. These are canceling. I have 5 times x equals 585. If I divide this by 5, x is 117 miles per hour. So that's still air. I would need to go ahead and plug that into one of my original equations, which was 2 times x minus y equals 180. I have 2 times 117 minus y equals 180. 2 times 117 minus y equals 180. Subtract 234 from both sides. Negative y equals negative 54, so our headwind must be 54 miles per hour. Okay, let's take a look at the next one. The next one, a biologist has 2 brine solutions. One contains 2% salt and another contains 8% salt. How many milliliters of each should be obtained to 1 liter of a solution that contains 5.6% salt? So the first one, I'm going to say that x is equal to liters of the 2% solution, and y is liters of the 8% solution. And I know that if I combine this many liters with this many liters, that I'm going to end up with 1 liter. I also know that I need a certain amount of the 2% and a certain amount of the 8% to get 5.6% of that 1 liter right there. Okay, so this is strange, but this is what my my system looks like. I'm just going to multiply those. There they are. I'm going to go ahead and multiply the whole top row of this by negative 0.02. That's going to give me negative 0.02x minus 0.02y equal to negative 0.02. And then this cancels the x's out. I have a 0.06y equal to 0.036, and I just have to divide both sides by 0.06, and that will give me y is equal to 0.6, I believe. Let me just do this. 0.036 divided by 0.6 is, whoops, hold on a minute. 0.036 divided by 0.06 is 0.6. So there it is. So we have 0.6 of y, and we need a total of 1 liter, so that means that x must be 0.4 of a liter. If I add those together, I will get 1 liter, and that liter will be 5.6% salt. Number 18, a boat on a river travels downstream between 2 points that are 20 miles apart in 1 hour. They want us to again find the boat's speed in still water, and then the boat's speed with the current. Speed in still water, and then this is the current speed. On the way down, it says that it was 1 hour. So the way down, we have the still water with the current increasing our speed, using distance equals rate times time. The time is 1 hour. The distance is 20 miles. On the way back, it took 2.5 hours. We had still water and the current was against us. And again, we were going 20 miles an hour. So if I distribute my 1, I have x plus y equals 20. And if I distribute the 2.5 for the return trip, I have 2.5x minus 2.5y equals equals 20. And I'm going to multiply this whole top by 2.5 so that I can cancel out y's. So I have 2.5x plus 2.5y equals 50 on top. 2.5x minus 2.5y equals 20 on bottom. When I combine these, my y's cancel. I have a 5 here, 5x. 50 plus 20 is 70, so x is 14 miles per hour, and 14 is the speed in still water. Now, if I want to find the current, I have to just use one of my original equations. This is one of them. I can plug 14 in for x. So if x is 14, y has to be 6. So my current had a speed of 6 miles an hour. Okay, we have one last question to take a look at. A researcher performs an experiment to test a hypothesis that involves the nutrients niacin and retinol. She feeds a group of laboratory rats a daily diet of 40.04 units of niacin and 23,040 units of retinol. She uses 2 types of commercial pellet foods. Food A contains a certain amount of niacin and retinol, and food B contains a certain amount of niacin and retinol. And she wants to know how many grams of each food does she feed this group of rats each day. So let's take a look at our variables. We are looking at trying to create things based on food A and food B. So A is going to be units of food A, or grams of food A, and B is going to be grams of food B. And we can say right now, if we're looking at niacin, we know that for food A, it has 0.21 grams of niacin, and food B has 0.23 grams or units of niacin, and that our goal for niacin is to have 40.04 units. So we're going to leave that there. Then we're going to do the next one based on retinol. So for food A, we have 130 units of retinol, and food B has 80 units of retinol. In total, we want 23,040 units of retinol. So we need to solve this system, and we're just going to focus on A. And basically what we're going to do is we're going to manipulate the A's to match by multiplying the top by 130 and the bottom by 0.21. One of those has to be negative for me to be able to cancel out the A's. So I'll make this one negative, and I'm going to distribute this to all 3. And I'm going to distribute this to all 3 by multiplying. So I'm going to do that. I'm going to pause and do that and come right back. Now that I've got these on here, I can cancel out my A's. When I'm combining my B's, I have 16.8 in the positive, 29.9 in the negative, so negative 13.1 B. And then if I am combining the last part of this, 5.2, this is negative 366.8. I'm going to divide both sides by negative 13.1. I'm going to get 28 for B, 28. In order to figure out how much I need of A, I'm going to have to go ahead and plug this into one of my original equations. So I'll just pick this first one. B is going to be 28. If I multiply 0.23 times 28, I get 6.44 plus 6.44. I'm going to subtract this from both sides. 0, 6, 3, 4, and then I have 0.21a is equal to that, and I just have to divide both sides by 0.21. 43.6 divided by 0.21. Okay, hold on, I just want to check one thing. Oh, okay, hold on, I did it. My math was, hold on, let me go back here. 40.04, take away 6.44. I don't know why I got what I did, but it's really 33.6. 33.6 equals 0.21a, and now I would divide both sides by 0.21. I had a little bit of a divided by 0.21. That gives me 166 grams of A. 166. We found A and B. That one was probably the most challenging out of all of them. Hopefully this helps with questions you had on homework 2. I will see you guys on Thursday.